All right, welcome to part 5 of our SQL series. Today, we're going to go on a pretty cool journey. We're starting with the simple blueprints of data storage and ending up building what I like to call an impenetrable data fortress. You're going to see that SQL is so much more than just storing stuff. It's about giving it structure, managing it, and most importantly, being able to trust it.
So here's the game plan. We'll start with the absolute basics, the blueprint. That means tables and how we bring some order to the chaos. Then we'll talk about the two big roles, the architect and the operator. After that, we dive into the messy reality of handling unknown data. From there, we'll learn some tricks to write smarter queries that do the heavy lifting for us. And finally, we'll put it all together to build that secure data fortress.
You know, every great structure, every fortress, it all starts with a solid plan, a blueprint. And in the world of SQL, that blueprint, that fundamental building block, is the table.
So, what is a table really? Just think of it like a perfectly organized spreadsheet or container. Each column has a specific label for a certain type of information. You know, like a name or a date or a price. And then each row is one complete record. It's the absolute ground floor for everything we're going to build.
But here's the thing. Having a perfect blueprint just isn't enough. I mean, storing data neatly is step one, sure. But we need to make sense of it, right? We need to see the patterns. If you just throw everything into the container without any thought, you don't get clarity, you get chaos.
And this is where our very first tool for creating that clarity comes into play, the order by clause. It's so simple but so powerful. It lets us take that jumble of data and arrange it logically. You can sort it alphabetically, by date, from biggest to smallest, whatever you need. It's how we start turning a random list into a coherent story.
So we have our basic structure. Now, who actually does the work? In SQL, it's helpful to think of two distinct roles, each with its own special toolkit. You've got the architect, who designs the database, and the operator, who actually works with the data that goes inside it. Now, this slide shows a really important idea in SQL. On the left, you've got the architect using DDL, or data definition language. These are the big, powerful commands like create that literally build the skeleton of your database. And on the right, you have the operator using DML, data manipulation language. These are the commands for day-to-day work, like inserting new data or updating existing records. And this separation is crucial. It means the people using the data can't accidentally bring the whole building down.
And here's a perfect example of the architect's power. Let's say your original blueprint needs a tweak. Maybe you need to add a new column for customer email addresses. You don't have to tear everything down and start over. No way! You just use alter. It's the command that lets your database design grow and evolve over time.
Okay, so we've got our blueprint and our tools, but let's get real for a second. In the real world, data is hardly ever perfect. It's messy, it's incomplete, there are gaps, and SQL has a very specific and very important way of dealing with this unknown information. This is one of those things that you absolutely have to get right. Null does not mean zero. It doesn't mean an empty space. It simply means we don't know. It is a placeholder for a missing piece of information, and understanding that is the key to writing queries that give you the right answers.
So, how do we actually handle these nulls? Well, one of the most elegant tools in the entire SQL toolkit is Coalesce. It's so clever. You give it a list of values, and it just scans through and gives you back the very first one that isn't null. It's perfect for plugging in a default value, like maybe not applicable, whenever you run into one of those gaps in your data.
Now, let's talk about summarizing data, because we do that all the time. Two functions are going to be your best friends here, count and sum. Count is like your tally clicker. It tells you how many of something you have. Sum, on the other hand, is your calculator. It adds up all the values to tell you how much. It's the difference between knowing the number of sales versus the total value of those sales.
All right, we have covered some serious ground. Now, it's time to level up. Let's look at how we can make our database do more of the heavy lifting for us by building logic and efficiency right into our commands.
The case statement is, well, it's like giving your query a brain. It's SQL's way of doing if-then-else logic. You can use it to classify data right in the middle of a query, like, say, labeling sales transactions as high, medium, or low based on their dollar amount, all in one go. It's incredibly useful.
And if you want even more power, you get to stored procedures. The best way to think about this is like bottling your logic. You write a whole series of complex SQL commands, you save it under a single name, and from then on you can run that entire complicated process just by calling that one name. It's faster, it's more secure, and it makes sure your business rules are applied consistently everywhere.
Okay, We've built our structure, we're managing the data inside, and our queries are getting pretty smart. Now it's time for the final, and maybe the most critical step. We have to protect it. We need to turn our data house into a data fortress.
When you boil it all down, data integrity is really about one thing: trust. Can you trust the answers your database is giving you? Integrity is what ensures your data is correct, consistent, and reliable. Without it, frankly, your data is pretty much worthless.
So, how do we build these fortress walls? SQL gives us a whole set of tools. We use constraints, which are basically just rules, like saying, this column can never be empty, or every ID in this column has to be unique. We use transactions to wrap up multiple changes into one package, so they either all happen or none of them happen. No more half-finished updates. And things like triggers are like automated security guards that spring into action when data changes. All these pieces work together to make sure our data stays trustworthy.
So there we have it. We've gone from a simple blueprint all the way to a secure fortress. Our structure is solid, the data is organized, its integrity is protected. But the journey, it doesn't actually end here. Because the whole point of doing all this work isn't just to store data, it's to get meaning out of it. And that leads to the next big question. Is the story your data is telling you the right one?